Hello students, here I am going to solve some problems which is based on the concept nucleophilic substitution reactions from the chapters haloalkane and haloarenes. Is it clear? As we know that the nucleophilic substitution reaction are nucleophile attack at the substrates and with the respective product. That is, the substitution takes place by the use of nucleophile and the product is formed is called the nucleophilic substitution reactions. As we know that nucleophilic substitution reactions such as SN1 and SN2. This is the SN1 is the nucleophilic substitution bimolecular and SN1 is the nucleophilic substitution unimolecular and this is a nucleophilic substitution is the bimolecular. Why do we call it the unimolecular? As we know that the rate of reactions are determined the first rate of reactions depends on the only substrate. Rate of reaction depends on only the concentration of substrate, yani only one molecules. But in case of the bimolecular, rate of reaction depends on the substrate as well as reagent such as nucleophile. That's why it is called the bimolecular reactions. This reaction, as we know that this SN1 takes place in the two steps and SN2 takes place in the single step. In SN1, we use the polar protic solvent and in SN2, we use the polar aprotic solvent. In SN1, as we know that the formation of carbocation and in SN2 there is no formation of carbocations, just formation of transition state. That is, as we know, SN1 takes place by a formation of carbocation, but SN2 takes place by the formation of transition state. So we recap these points, and on the basis of this point, maybe we are going to solve some problems. One more thing is that when we look the order of reaction in the different carbocations, so the order of 3 degree carbocation, 2 degree and 1 degree. In SN2, the order of reactions 1 degree is faster, 2 degree is slower than, and 3 degree is very slow. So now here the problem is given. Which alkyl halide from the following pair is chiral and undergoing which SN2 reactions? This is which of alkyl halide from the following is chiral and undergoes SN2 reaction? The first of all, we identify the chiral. Here the compound is 1, 2, 3, 4. This is 1 bromo butane. 1, 2, 3. First of all, write the name. This is a 2 bromo butane. And 1, 2. Here see, at carbon number 2 is the bromo, 2 bromo, and 2 methyl. methyl butane. Now, how we will check the chirality? If chiral center means having the four different group A, B, C, D. So look here, it has the CS3 same, but here the hydrogen and here the hydrogen. Two groups are same, so it will not the chiral. It is not a chiral. Here this is a hydrogen CS3 and CS3CH2. So it has the four different groups. So we can say that this is the chiral center. So 2-bromobutane will be the chiral. Same as CS3 and CS3. So two groups are same. So it will not also chiral. So here the B 2-bromobutane is a chiral compound. Clear? Now, second, which is undergoes faster SN2, or we can say that arrange the following also in increasing order of SN1 or increasing order of SN2. The questions may ask in such way also the same question. So now let us see, as we know that the order of reactivity in SN1 is the 3 degree, 2 degree and 1 degree. SN2 3 degree, 2 degree and 1 degree reverse of SN1. Now first of all identify the degree of carbocations which is formed after removal of the leaving group. When bromine will remove this carbon having the only one carbon. So this is the 1 degree. It has the 1 and 2 carbon, 2 degree, and it has 3 carbon, 1, 2 and 3 carbon after the removal. So it is the 3D. Now arrange SN1, that is C will go faster, then B and then A. In case of SN2, that will be A, then first degree, then B and then C. So this is the answer of this given question. Now let us see, we have another problem. C6H5CH2Br, C6H5CS, C6H5CS, C6H5CS3Br or C6H5CCS3, C6H5Br. So first of all, we need to identify the intermediate, that is a 3 degree, 2 degree or 1. So when we look it, so it will be such as CH2Br. That means it is a 1 degree, only one carbon. About it, C6H5, CH, and then this is the Br. So this carbon is the 2 degree. What about it? C6, sorry, the Br is connected to this carbon, not that. C6H5 CH, it has CH3 and Br. And about it, C6H5 C, and it has CH3, Br and C6H5. So what about it? It is connected to the, this carbon is connected to the 1 and 2, 2 degree. This carbon connected to the 1 and 2. So this is 2 degree, and this is connected to the 1, 2 and 3 degree carbon. Now, let us see the order of SN1. So, first of all, this is a 3 degree, no any square. So, D, then after that, 2 degrees. So, let us see, here there are in the 2 degree, there are the two compounds. This 2 degree having the two phenyl group, 2 pH group, phenyl. That's why it is a more stable rather than it. So this is a B and then C and then followed by E. What about SN2? 1 degree is the faster, that is A. Then after that in 2 degree. So this is the less stable, that will become C, then B, and then later on D. So this is the answer of the given question. Now, see another question. See another question. Two chloropentane, one chloropentane and two methyl pentane. When we come when the problem is like that, then first of all uh, need to convert it into uh, structure. So 2 chloropentane means CH3, 10 means 5 carbon, CH2, 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 1, 2, 3.